This discussion is about the concept of zero stress level with experimental analysis and historical wooden panel paintings and numerical nonlinear analysis. The work was made in strict collaboration with the Opificio delle Pietre Dure. So let's start saying what the zero stress level is. The zero stress level is the optimal hygrothermal condition for the conservation of wooden panel paintings, and is the situation where stress and strains on the paint layers are minimal. That means that is the best situation for conserve them. So some key question would arise. Does it exist such a condition? Is this condition, can be this condition experimentally identified? Is it physically explainable? And does it match real-world observation? So going straight to the point, we may say that if wood is extending, it puts into tension the ground layers and the paint layers. If we assume somehow that paint layers and ground layers are cracked somehow, we may say that cracks would be opened by this tension, and only a small part of the section would continue reacting to the forces. While when wood is contracting, the fissure would close, and the whole section would play a role in the compression with the cracks that are closed. Now, the idea basically is if I have a condition of moisture content or RH where I have this zero stress level, and I put my painting having two variations in humidity, the first descending and the second one going up in humidity, I would see this kind of change in state. So basically I can assume that here with high humidity I will be in such a condition, while here, where the wood would contract, I would be in this condition. So if the zero stress level is beneath this variation, I will have a condition where cracks are opening and closing. So the limit condition of opening and closing of the crack. And of course, this situation, when cracks start to open or start to close, they are the condition where the paint layers are subjected to zero stress. The idea is to put in place a method to experimentally measure this kind of behavior and identify experimentally the zero stress level. So we said that is the balance point between compression and tension, and that in this situation we have the minimum internal coaction between wood and paint layers. So we have the minimum transfer of forces between the two systems. Now, we have to say that conservation standards and norms, they have inside somehow the concept as hypothesis of the zero stress level, because they rely on the concept of acclimatization of the artworks. So behind this, there is the idea that during acclimatization, the art piece arrives to a level of minimum stress and strain that is the ideal for conservation. But these ranges are generic, let's say, and they are not taking into account the artwork specificity. And also, the historical climate is not critically assessed with respect to actual art pieces. Then there is another point that is important, that there is no consideration of the aging and on the actual state of the painting. So if we can do that, it seems to be the better preservation possible, with minimizing the risk of damages. But also we may think about energy efficiency in museums and conservation in general, because I can think about narrow ranges of humidity for more sensitive paintings, while I can adopt wide ranges for more stable work. And we have also to say that in numerical modeling, we need to put a reference situation at a certain humidity and moisture content. Normally, it's arbitrary how we put this condition. If we have the possibility to put the right condition experimentally determined inside the model, we will have digital twins that may say to us exactly what would be the stresses and strains at certain level of humidity. So some hypotheses to put on the ground all of this is that paint layer stiffness significantly affect the deformation behavior of wooden panel paintings. They are affected by cracks and micro cracks. The crack stiffness has a role of diminishing the stiffness of the paint layers. And as the paint layers are very thin, we may say that the transition between tension and compression is simultaneous. So we want to do some cycles of humidity on paintings and see if going down or going up, the deformation is the same. If it's not the same, it seems that it demonstrates that there is a change in rigidity of the paint layers. So here is the test specimens that are 6 paintings of the Opificio delle Pietre Dure that they were chosen from their expert restorers to represent 6 different typologies related to the ages of the Florentine school. They were equipped, they were equipped on the back with the formometric kits that permit to monitor in real time and in continuous time the capping of the panels, so that we have the possibility to follow in real time what happens to their deformation. Here we show the climatic box we created for the panel paintings, and this climatic box permits us to do some changes. What we are doing here is this kind of change from 60 to 53 and then again to 60 to see if in the middle we will have that zero stress level. Now, some of the variables are strongly coupled the one with the others. The emissivity of the paint layer, so the vapor that migrates inside the wood from the paint layers, is strongly related with the rigidity of the paint layer. So as this experiment mean to measure the stiffness of the paint layer, we isolated this variable, putting this film that create a totally impervious surface, neglecting the vapor exchange on the front and exalting in this way the rigidity of the paint layers. So these 6 paintings exhibit capping. Please watch this one. Here we have days. Here we have the capping angle, so how much is the distortion of the painting. And we see clearly that in the 2 cycles, this is the first cycle, this is the second cycle, there is a different pattern. In general, we have 3 paintings that exhibit different patterns, and 3 paintings where the 2 curves are perfectly matching. We would speak only of painting number 1, as the other one are more or less the same, the methods are the same, etc. So we see that the steady state, so the equilibrium situation, is different from the 2 for the same variation of humidity, and in general, the dynamics of the curves, they are totally different. So we may say that for this painting and for the other, we may experimentally understand that there is the 0 stress level that goes inside the range of humidity that we tested. So we decided to calibrate a model on the readings we have from the deformometric kit to understand the wood stiffness, the wood transverse diffusion of moisture, the wood hygromechanical expansion, so the swelling and shrinking coefficient, the emissivity of the back bare wood, and the paint rigidity that is complex because here we have also damage. Because as I said before, we are speaking about fissures and cracks. So going back here, we need to basically model this kind of behavior when the painting, when the paint layers are under tension. We want that the cracks are open. When they go into compression, we want that the crack are closed with the restoration of rigidity, because in compression, the whole section would work. So to do that, we are using a damage model that sees the initiation of damage for 0.2 strain and the ultimate damage, so the 0 stiffness at 0.5. But now a problem is emerging. How we attribute this damage to something like that? What is the magnitude to have the right damage? We saw from our models that both without crossbeams and with crossbeams, the main stress and strains are in the zone where the planks of wood are tangential. So to create something that goes in this direction, we decided to create, before the simulation of the test, some fictive damage cycles, let's say 1 cycles, from up to down, to simulate the damage. Now, this variation of humidity that creates the damage is part of the optimization procedure, because we want to create a fictive damage that somehow is compatible with the difference in the readings that we have from the experiments. Okay. So here we see how the simulation is working. More or less, it's the same result that Marco was showing before, where the damage that we optimize really can catch how these 2 curves are different, the one with the other, because they represent 2 different rigidities. One with the cracks opened, and the other one with the cracks closed. Here we see the result of the model, the level of damage that we are calculating in this zone where there is the deformometric kit. So it has this situation that is what we wanted to do, in the sense that the peak is in the tangential zone of the plank, but with a posteriori analysis on what happens in the painting, we see very clearly that in flaking light we have strong vertical cracks, so cracks that are in the direction of the grain and perpendicularly to the direction of the wood expansion, transversal wood expansion. And so we have a very good match a posteriori between the damage that was calibrated on the actual test and what we are seeing from the actual picture of the situation. Here I have a damage that is very, very high. It's 90% in this zone. And what I would expect from this kind of damage, I would expect Japanese paper that is protecting a possible loss of color. So we have a total, let's say, destruction of the rigidity here in this zone. Now, we may say that for this panel, the stress level is inside this range, and that from our sensitivity study is more or less in the middle, so 57%. But there is something else that is very important. As I said before, as I said before, we calibrated a damaging cycle. So we have a fictive variation in humidity that generated a damage compatible. This variation of humidity in moisture content is this result. So the idea is now to convert this variation in moisture content in a variation in RH. As the panel was damaged in the boundaries of this in the boundaries of this variation, I may say that inside that boundaries, the painting will not be damaged anymore. It would be damaged if the climatic condition would be equal or would exceed that level. If it is inside that level, the panel is, let's say, quite safe. So let's say we had 6 paintings. 3 of them were showing this kind of behavior with 2 curves that were very well distinguished, the one with the other. And in 3, the 2 curves were totally matching, let's say. In the 3 that were showing the 0 stress level, so the 2 curves that were different, we see clearly that there are vertical cracks in the direction of the grain of wood that are very deep, and they go through the ground layers. There are also other quadrangular cracks, but they are kind of superficial. While in the 3 paintings where the behavior showed 2 curves that were matching, we have only quadrangular cracks, very superficial, that didn't go through the ground layers. So going to the too much conclusion. Going to the conclusion, we may say the whole of this, that is exist, that can be identifiable, that is physically explainable, and that does match as validation what we really see inside the paintings. But the most important point is this, that this work opens the methodological basis for energy efficient management for museums. We saw that, for example, for these paintings, let's say the levels of the 0 stress level and the boundaries that we obtained that are more or less this. They are more or less the same for all the three paintings. I don't want to give you magical numbers. They are not. They are the consequence of an experimentation on these specific 6 experimental paintings. But in these 3 paintings, more or less we have this range that assure that these paintings, without crossbeams, with some margin, of course, because we are dealing with models, they would be in a situation of no damage. This means that for collection, for conservation, for museums, we may say, if we do this kind of analysis and we go in this direction, that we know the well-being RH, and that we know a range of humidity that is not a magic number, but is extracted from experimental data, where this painting would be safe. So at the end, we may say that we have the 0 stress level. We calibrate a digital twin going in an absolute modeling because we have the 0 stress level. We can understand with the digital twin what may happen if we put crossbeams, if we have to do a restoration on the paintings, if we want to understand if a climatic system of a museum can be used with the ranges of the norms, or we can extend this range because somehow the experiment were showing us that the paintings were somehow safe. Thank you.
We'll start up there. Yeah.
I don't, okay, it's working. Thank you very much. Could you explain to me, maybe I just didn't realize, but how did you calculate 90% damage? How do you define the damage?
So we are doing an optimization procedure. In an optimization procedure, we have some experimental data, we have a model, and we have some variables that we variate to make the model acting like the experiments. And we decided to optimize this value plus the value of these cycles that are putting in high stresses in the paint layers and damaging it. This cycle is damaging the paint layer in a way that is compatible with what we are reading from the experiments. Of course, no one knows actually what damaged the painting. Because, for example, the crossbeams we have here, they are not the original. They are object of the restoration that they did at the Opificio delle Pietre Dure. We don't know where the panel was stored. We don't know anything of his story. Only the very recent story when this kind of damage were already be done, let's say. What we want to say is, what we want to see actually is, from the damage that I'm reading in the difference between these two curves, what is the possible range of humidity that can cause a damage of this amplitude? I don't know, I hope...
So 90% means the loss of rigidity is by 90%.
By 90%, yes. So sorry. So 90% here means that if the initial rigidity is, I don't know, 100, in this zone, it's 10. So it's a reduction of the 90% of the uncracked rigidity. So to come back, because I know that is a bit tricky. Between this situation and this situation, there is a difference of 90%.
Hi, thank you for your presentations, both of them. I understand that this project has been done in collaboration with the conservators of this Opificio delle Pietre Dure, and that the original question was, how much force are we supposed to give to the springs in order to stabilize the painting's behavior?
Let's say the original question was the original, because one question follows the others. It's like a big train that arrives from Florence to here in LA. So let's say the first primal question was, as a restorer, I have to do some changes for restoration at the crossbeams because the previous crossbeam were too stiff and they ruined the paint layers. So how much stiff has to be the crossbeam to be respective, to have respect for the well-being of the art piece? Then
okay.
one question.
Is there any answer to my question about the springs force? Do you have any answer for my question of the spring force?
Yes. The answer is that it's strange. The answer is not what you are expecting. The answer is that the springs are the way for the restorer to have a fine adjustment of the containment that is done by the crossbeams. So I designed the crossbeam to have a containment of the strain, of the capping of the painting that is respectful of the painting, that will not cause cracks. And here the need to create digital twins because we needed to understand the stress and the strains. And then we decided, okay, we would do a good design, a well-posed design of these crossbeams, and then we would leave to the restorer the possibility to adjust it with springs. So this is actually the logic.
I think there's one more up there somewhere. Yeah.
With the zero stress level that you've measured or estimated, how does that relate to the historical environment for the paintings?
How it relates to the past relative humidity formation from the terms of historical houses?
Let's say, for us it's a bit difficult to say that because these paintings were in the laboratory of the Opificio delle Pietre Dure, in the storage room, so it's a bit difficult. And it's a bit difficult also to understand, because the problem, if I understand correctly, is the problem of acclimatization. You are asking this. It's a bit difficult to answer well at your question, because actually we don't know what happened in the past centuries, but also in the past years. Let's say that the number for the zero stress level we obtained, it's compatible with the average that we are reading in the site where it was stored. But I don't want to say also this as a magical number, but it's compatible, let's say. I don't want to say that it's acclimatization to cure.
But the compatibility gives us some confidence that using recent past environments is not totally different from what you're measuring. I do take your reservations
No,
into
it's not
account?
totally different. And I think that the norm, I was criticizing the norm, but in a good manner, in the sense that I think that the logic behind the norm is correct, my opinion. What we have here, we have, firstly, the point that it exists. Because we didn't know that it exists, that if it existed. Secondly, that we can experimentally verify this, so we have a methodological framework. Then that we have a safe range to relate, and this is far bigger than what the norms would suggest.
Okay, let's thank Lorenzo again. So thank you very much.